Okay, welcome to section 1.6. This is the overview. So we're just going to cover some of the rules, and then we'll get into the examples later on. Well, let me pull up the list of rules here. Okay, so we've got the first rule: a to the first power equals a. So this is for any real number, a. You got a to the first power equals a. So for example, 2 to the first power equals 2. Negative 2 to the first power equals negative 2. 17 to the first power equals 17. 31 to the first power equals 31. So on and so forth. So on and so forth. So, okay, moving on. A to the 0th power equals 1. So this is actually a little different. This needs to be not 0. And I'll explain why in a second. A needs to not be 0. But for any other number, a to the 0th power equals 1. So for example, for say 2 to the 0th power, that'll equal 1. Say negative 3 to the 0th power equals 1. Now those parentheses are important, and I'll explain that in a later video. But essentially, so every real number that's not 0 to raise to the 0th power is just going to be 1. Now, 0 to the 0th power is an ambiguous case. Some mathematicians think it's 1, some think it's 0, so just ignore that. That's ambiguous. I'm not going to ask you to try to prove that it's 1 or 0 or something like that. So just ignore it as 0 to the 0th power. But 2 to the 0th power equals 1. If you take negative 3, all of that to the 0th power, that's just 1. Okay, so the next rule, the negative exponent rule. So a to the negative n, or as n is any integer and a is any real number, a to the negative n will be 1 over a at the end. So for example, we've got, say, 3 to the negative 4. That'll just be same as 1 over 3 to the 4th. If you've got 1 over 2 to the 6th power, that's the same thing as saying, okay, that's 2 to the negative 6. All right, moving on, we've got the product rule. So we've got a to the m times a to the n, where a is a real number, m and n are integers. A to the m times a to the n equals a to the m plus n. So I'll give an example, and you need to make sure that these two bases are the same before you use this rule. So for example, you've got 3 squared times 3 cubed. That equals 3 to the 2 plus 3, which equals 3 to the 5th power. Now make sure, again, you need to make sure that these two bases are the same. So 3 and 3, those are the same. So you can use the rule. But you can't, for example, try and apply this rule if you've got 3 squared times 2 cubed. These bases aren't the same, so you can't apply the rule. So just something to keep in mind there. So, okay, so there we go. Got these done. And finally, we've got the quotient rule on this page, or this whiteboard. A to the m over a to the n equals a to the m minus n. So for example, if you've got 3 to the 5th over 3 squared, that equals 3 to the 5 minus 2, which equals 3. Now again, you need to make sure when using this rule that the bases are the same. So you can't, if you have 3 to the 5th over 2 cubed, you absolutely cannot use this rule because the bases are not the same. 3 is not equal to 2. So you could not use that rule then. Okay, so that covers all the rules on this page. And we've got, it looks like, 2 more rules. So I'll go over those. And if this is a little fast, you can always pause the video and rewatch parts, or shoot me an email. I'm more than happy to answer questions over email in class. However, make sure you understand this part. We'll have plenty of times to go over it, but it'll be important to have a good handle on your exponent rules going forward here. So we've got raising a product to a power. Okay, so a times b to the n equals a to the n, b to the n, and a over b. Oh, I want to do this in order. Let's see. Oh, we can do it. This is good. A over b to the n equals a to the n over b to the n. We actually have 3 more rules. So raising a product to a power, raising a quotient to a power, and this is out of order, but also the power rule. We need a to the m to the nth power. Okay. So first, raising a product to a power. We've got a times b to the nth power equals a to the n times b to the n. Where a and b, those are real numbers, n is an integer. So, for example, you've got, let's see, say 3 times 2 to the nth power equals 3 to the n times 2 to the n. You could also say, okay, if it's a number, 3 times 2 cubed, that equals 3 cubed times 2 cubed. And then if you have, say, 3x cubed, that'll be 3 cubed times x cubed. So those are some examples of when you need to use that rule. Okay, so now for the raising a quotient to a power, you've got a over b to the nth power equals a to the n over b to the n. So for example, if you've got, say, 3 over 5 to the 3rd power, then that'll just be 3 cubed over 5 cubed. Or if you've got, say, 1 over 6 to the 4th power, it'll just be 1 to the 4th power over 6 to the 4th power. A to the m to the nth power, that'll be, say, okay, so say a is, I don't know, 3, m is 6, and n is 3. So it'll be 3 to the 6. Oh, here, I'll write out the rule first. That'll be a to the m times n. So, say you've got 3 to the 6 to the 3rd power, then that'll just be 3 to the 6 times 3, or 3 to the 18th power. Or I can do another example. Say you have 2 to the 4th power cubed. That'll be 2 to the 4 times 3, which will just be 2 to the 12th power. So hopefully that gives you just a good introduction. If you have any questions on this, feel free to email me. If you have any questions on the homework, definitely ask in class, email, etc., and we'll get it figured out. Thanks for watching.